All right, this is lesson 9.7. We're analyzing piecewise graphs, or graphs in general. For number 1 through 4, the easiest way to do this is just to look at the picture and remember that the number inside the parentheses represents your x. So if my x is -3, go -3 on the x-axis and look for your graph. If I'm at -3 on the x-axis, I'm already hitting my graph, so my answer is 0. I don't have to go up or down to find that graph. Let's see about -2. If x is -2, I'm -2 on the x-axis, which means I need to go down 1, 2, 3, 4 to find my graph at y is -4. Basically, this is saying, okay, my x is -2, my y is -4 to get me to this coordinate point right here. If my x is 0, that means I have to go all the way down to this coordinate point to find the graph, which is at -1, 2, 3, 4, 5, 6, -6 for my y value. If x is +2, I'm right here, which I'm already on the graph, so that means I don't have to move it all up or down, so I have a y value of 0. For the next one, if my g is of x, or my g of 0, my x is 0, I need to go down 2 spots, or maybe is it 3 spots? This is kind of blurry. I would say probably 3 spots right there to find my x or my y value of -3. 1, 2, 3, yep, down 3 spots. And then if my x value is 2, I'd go over 2 on the x-axis, and in this case I need to go up to find my graph. If I go up 1, 2, 3, 4, 5, I find my graph right here. Again, my x is 2, but my y is 5. Next, my x value is 3, so I'm going to go over 3 and go up 6 to find this point right here, so 3, 6 would be my answer. And then if I go over 5 and go up 2, I find my graph right there. Again, this is your x value, this is your y value. So if my x is at 5, where is my graph? My graph is up 2, so my y value is 2. Okay, on this one, I have h of -4, so I'll start at -4. That would lead me to this spot, so go down, which would put me at -1 there. If I'm doing h of 0, I'm here, which means I need to go up 1, 2, 3 to get to my graph right there, so up 3. H of 2, I'm right here, which means I need to go up 3 again to get to my graph. If my h is at 4, my x is at 4, I'm here, so that means I need to go up 1, 2, 3, 4, 5 spots to get to my graph. So my y value is 5. I input 4, I output 5. On number 4, I'm going to input -3. So on my x-axis, I'm going -3. My output then would be up 2, so +2. Or on 4b, I have -1, which means my y value is +1. At 0, my y value is 0, and at x equals 5, my y value is 2. All right, let's take a look at the next group. It looks like we have a little story and a graph. Isaac lives 3 miles away from his school. It looks like my graph here has the distance away right here. So this is the distance, and this is measuring the distance he is in miles from home. So this is 3 miles, which means that he's at school right there. Okay, school ended at 3 p.m. Oh, look, the bottom is representing time. So this means if he's at school, it's 3 p.m. And then each little increment past there is a half an hour after 3 p.m. Okay, school ended at 3 p.m. and Isaac began his walk home with his friend Tate, who lives 1 mile from school, in the direction of Isaac's house. Isaac stayed at Tate's house for a while and then started home. So let's see if we can see where Tate's house is. Maybe this represents us walking home. Our distance is getting smaller. We are coming home, so we're getting closer to home. So our distance is going down as time increases, and then our distance stays at the same place. In other words, we stay the same distance away from school for a while. This flat line must represent Tate's house. And it looks like he stayed there from this point to this point, or in other words, 2 hours long he stayed at Tate's house. All right. On the way, then he got going on the way home again, and he stopped at the library. So you can see him kind of traveling again, and then he stopped at the library. So here's the library. And then it says, the graph to the right is a piecewise defined function that shows Isaac's distance from home during the time it took him to arrive. So let's answer question A. How much time passed between school ending and Isaac's arrival home? He finally gets home all the way over here at the very end. So let's see. He left at 3 p.m. and then he went all the way 1 hour. If you notice, you have to go in increments of 2 because each little line is a half an hour. So 1 hour, 2 hours, 3 hours, 3.5 hours, 3.75. So how much time passed? 3.75 hours. Remember that if you wanted to turn 3.75 hours into hours and minutes, then you would have to do 0.75 times 60. 0.75 times 60 is 45, which represents, okay, we had 3 hours and 45 minutes. The way I converted it to this, from this to this, is I took the point, I knew I had 3 whole hours, and then 0.75 times 60, because there's 60 minutes in an hour, so 0.75 of those 60s represents 45 minutes. All right, next one. How long did Isaac stay at Tate's house? Oh, we already answered that question. He stayed for 2 hours. And you can see that here. Remember, each of these little tiny boxes is a half an hour. So if he stayed 4 half an hours, he stayed 2 whole hours. Part C asks us, how far is the library, which is right here, from Isaac's house, which is here? So really we're measuring distance, so we need to look up and down vertically. It looks like the library is right here and home is at 0. So what is the distance right here? Well, it's just 1.5, looks like miles, 1.5 miles. And then where was Isaac 3 hours after school ended? So let's look at the bottom here. We have to go over 3 hours. Here's 1 hour, 2 hour, 3 hours. Just follow that line up. Oh, he's at the library. And then last but not least, when was Isaac walking the fastest? This question is asking you about slope. Where is the steepest slope, or when did he cover the most amount of space, the most amount of distance in the least amount of time? So the steepest slope. If you look, I think the steepest slope is actually right here on his walk home. Maybe he realized he needed to be home soon, so he walked extra fast. Okay, you can calculate each of these individual slopes, but I think it's on his way home from the library. And then it asks you how fast he walked. So we need to talk about the slope, or the difference in the y's over the x's. So if I'm here and I'm basically going to connect these 2 points right here and right here. So if I go straight down and then over, I'm looking at that rise over run. Let's do the difference in the y's and the x's, since we actually do have those coordinate points. It looks like my y values, I'll write these points out for us. The top value here is 3.25, 1.5, and then this home value here is 3.75, 0. Let's go ahead and label these points. I have an x1 and a y1, and then we'll call this like my x2 and my y2. So if I were to do this, plug this into the slope equation, I basically have, like, I'm going to do my y1, which is 1.5 minus 0, over my x2, which is 3.25 minus 3.75. So that gives me 1.5 over 0.5, which basically says, okay, I'm walking 1.5 miles in 0.5 hours. Remember, x is representing the hours, y is representing the miles. So I'm walking 1.5 miles in 0.5 of an hour. Remember, we usually measure speed in miles per hour, like whole hour, not half an hour. So if I wanted to change this from 1.5 miles in a half an hour, and I wanted to say that this is a whole hour, I could just times both the top and the bottom by 2, right? Because the bottom then would be 1 whole hour, so 1 hour or mile per hour, and then the top would be 3. He's walking 3 miles per hour in this section of the graph, or in other words, he'll get 1.5 miles in 1/2 of an hour. The next graph here is completely up to you for this story. You can be as creative or as lame as you want. You basically just need to make a story that will fit this graph. When you do that, make sure you discuss what this is measuring and what this is measuring. On my answer key, I put a story about a unicorn flying in the sky. I think this is supposed to measure her elevation over time or something like that. Be specific with this because you need to be careful. If you do in fact say that this is my elevation, notice that this person, whoever he is, if he's hiking a mountain or whatever, starts at ground level, goes up and then stays in one spot, stays at one height for a while, goes up even higher and then comes down not to where they started from. So somehow they're going to stop somewhere high up in the sky. My unicorn, I said, went for a flight, and then they stopped and took a rest and then flew some more and then came down and found a castle in the clouds and stayed in the sky and lived there forever. Okay, you could also do this as a hiker, hiking up, finding a place to stop and take a break, going up even further and then hiking down and then maybe camping for the night, like they're stopping here up high in the mountains. You could also do this where it's not measuring the height, maybe it's measuring the distance or the speed in which someone is traveling over time. You can decide however you like and make a story however you like, as long as it explains why the graph goes up, stops and stays at the same place, goes up, comes down, and does not end where it starts. So be creative with your story. If you want a full example of my story, you can check my answer key on delamath.com in the answer key folders of chapter 9. For part B, it says, if you were to write an equation to match each piece of your story, how many would you have to write? Well, it looks like I have a line, a line, a line, a line. So I would say 1, 2, 3, 4. I would have to write 4 different equations because there are 4 different lines happening. Here's 1, 2, 3, and 4. So 4 different equations.